Okay, it's now recording. So welcome to today's session. We'll be explaining practical 5, right? I'll show you how to set it up and then explain the file handling part. Then also maybe do a bit of few functions there. Yeah, I just do a bit of few functions. So we have the starter code. Then I'm going to do this because I don't like it repeating the same folder. Then yeah. Oh, so you just open the code inside you're inside Eclipse. Yeah, this is convenient. So I'm gonna open the PDF here, and then 110 marks, crazy business. Imagine you get zero. Let me close this. Mm, just give me a second. Why is it not closing? Because I don't want to make my laptop too. It would manage, but I don't want it to start making any noise. So this is practical 5. Within Nova, drama unfolds. A fellow developer, perhaps more of a code enthusiast, has been given the boot for their, let's say, unique approach to data structures. Data structures, right, is basically it's a convenient way to structure your data. For example, arrays. They're structured as contiguous blocks of memory, right? Contiguous meaning one after the other. This is just a fancy way of saying one after the other. Like in a queue, for example, when you're at Pick and Pay or at Capitec, at the Capitec ATM on a month end, you know how long those queues be like. So that's basically a way of structuring the data. In that sense, the data would be the people. That would be the data. So that's how you'd be structure those people, right? That's a different approach, right? There is other approaches. Just remember, it's not just about storing data, it's about storing it with type safety, right? Type safety. Their implementation was memorable, though for reasons they'd hope. And then blah, 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 blah. There's just a lot going on here. I'm not going to be reading everything. So we're going to look, I think we can start here. Let me see, with Nova. Infinite wisdom, blah, 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 and irrelevant. Then here, yeah, we're gonna start reading from here. And one important thing that I noticed students don't pay attention to, you see this part here where it shows a 1 and a 2. They usually put very important information here. They once did that to students last year. They lied and they said the practical is in session. Then they put a comment here and said, if you are reading this, that means you know how to follow instructions. Don't worry, the practical is actually due next week. Let the ones who are confused stay confused, and then you can just relax. And people were busy coding only to realize and then they announced after, like when the session was about to end, that guys is actually due tomorrow or next week. I mean, check, we're checking if you guys read the instructions. So this part here always has very important instructions, so normalize checking there. So first you need to adapt the solar system class to use an array list, right? So basically they're saying in fancy ways, um, update the solar system class. Instead of using a normal array, make it use an array list, which will basically do the exact same thing. So in the previous practical, when you're creating an array that grows automatically, you're actually implementing an array list. So now instead of implementing it, you're just going to use it because it's already part of Java. So this was ComSci 3A students. Forgot to close this. So let me close here. Close project. Then I'm going to say file and then open projects from file system. right? You click open projects from file system, then you click on directory. Remember another word for directory is folder. So you have to look for the folder which they gave you, which is P05 starter. Then select that folder and then make sure here everything is selected, right? By default, it's going to select everything, but just double check here and then just click finish. And then you've successfully imported your project into Eclipse. Then we're going to have our main. We should test our code. Then we're going to have, yeah, okay. I was thinking about something, but I can't apply it here. So, but then it's fine. So we need to update solar system. And then celestial body. I don't know if we're supposed to update that code. I don't know. E-color, moon, blah, blah, blah. We'll see. Let's start with solar system, right? Oh, this one is straightforward though. I think the main important thing or the new thing here is the file handling part, the binary files, right? And then we have a jar file. So we can include the jar file, right? Remember, we need to include it to our build system so that when Eclipse builds our project, it also builds the jar file because we're going to use things from the jar file. So I'm going to right click on the jar file, then I'm going to click on build path so that I add it to the build path. Basically, it's going to be part of the files that will be built by the Java compiler when it compiles all of the files. So I'm going to say add. Then now I can actually use functionality from here, which is just the test in this case. Yeah, straightforward. And it's a static method. Remember, we talked about static method. How do you know something is static? You know something is static when it has a red S there, that capital letter S. That means static. And then that if it's a green C, that means it's a constructor. So that's a cute way of knowing things. But then I already know this class. I just added it to build path. That's all I needed to do. Then I'm going to go to my code. So we need to do different things now, right? So we need to stop using, I'm not sure about the grow array, whether we need to delete. We'll see what the question says. So first you need to adapt the solar system class to use an array list. So that means we should delete the array and use an array list. While you're at it, methods to retrieve the solar system's name and bodies will be useful. So we need to create accessors. They said retrieve. It's just English. That's why I'm going to keep reminding you how important English is. Retrieve just means to get, to access. So accessors that get the solar system's name and the solar system bodies in plural. Because inside here we had an array. So that means here I need to come here and say array list, right? I'm kind of technically giving you guys the answer. This is not, I won't complete everything. I'm just going to show you a few things. I won't do everything. So we have that, and the new celestial body. We we don't need to do this, right? You see this? You don't, you need to change a few things. To initialize an array list, right? Remember, we're gonna say new, followed by the array list. Remember, it's generic. Then you pass in the type here, celestial body. But since Java, I forgot which Java version, you can omit the type here only when you're calling the constructor. Then you just put it like this. Then you can, if you wanted to pass in an initial capacity, meaning it's starting, yeah, you see, the initial capacity for the celestial body. So this is actually the capacity. So that means I need to pass it via the constructor here. So num bodies. So this will be the array list, and then if you check the documentation, right, the parameters here, you see, it tells you the parameters. Initial capacity is the parameter that you should pass. And they did tell you that initial num bodies is the initial capacity. So that's the only thing I need to change there. Then I scroll down. Then we need to fix this part over here, right? So remember, now we're not managing everything manually, right? So there's no more this thing of increasing the array size if the array is now full. All of those things, I don't have to do all of that. The array list manages everything for me. You see this array list class? It manages everything for me. So now I'm going to just simply wait, body index. Nah, I don't need, yeah, you don't need to maintain all of this. So body index, you see this variable over here. You don't need to use it anymore. So I'm going to have this, and then I'm going to show you how powerful array lists are. The only thing I need to put here is bodies, which is my array list, remember? Then I call them, there's a method called add to add something into the array list. So dot add, and then I add this celestial body, and then done. That's literally all you have to do. So the this practical, to be honest, it's actually easier than all the other practicals. So here I'll just leave this one as it is. The grow array is not needed anymore because the array list it manages its memory on its own. So it grows the array on its own. So you don't have to have the grow array method, right? It's no longer needed. And then count celestial bodies. Now we need to update a lot of things. Remember we had that bodies array, so we need to count one by one and do all of that. Now we have an array list. Things are easy. So I delete everything and I simply return bodies. Inside array list, right, there's a function called size, which returns the number of things in that array. So dot size. Then done. So like I said, this practical is actually fairly easy and straightforward. Then we're gonna have celestial bodies, but yeah, the rest of the code is fine. To be honest, the rest of the code is fine. So that's the only parts. Those are the only parts I needed to change. It's here, returning the size, because now the array list itself. Remember, array list is a reference type. So we can, if you wanted to, I think you can open declaration. No. How do you go to this definition? Mm, uh, open. Okay, I can't see. I don't know. Sometimes it works, sometimes it doesn't work. It was supposed to show me the declaration, the class itself, but then it's fine. So we needed to add two new things. Remember, they told you should be able to. They said it'll be useful to be able to get the name and the celestial bodies. So I need to create accessors for those two things. So after here, I'm gonna create an accessor. So public void because it's an accessor. No, not void. That's a mutate. So what am I returning is a string because I want to create an accessor for a name. Then I simply return name. Then I create an accessor for my array list, which is going to return an array list of type celestial body, right? And then it's going to be called get bodies. And then you're going to return bodies. Why am I saying it should return the array list of this type? Because that's the data type of that variable. This is its data type. So that's why I'm returning that data type. Then don't forget your Java doc because there's marks for that. Mm, yeah, you can explain all those things. That's up to you. You can put whatever you did. This is HTML. You put a paragraph. This P stands for paragraph, HTML. So you're writing a paragraph explaining what does this mean. So this is the name of the solar system. Simple as that, done. You don't have to do all of that. Just as long as you put Java doc and it has that at return, that's fine. Like just like this. Or you can just write text here. That's up to you. And then it's done. I think it's complete. I think the class is complete. Yeah, we are done with solar system class. And then let's see. Okay, I'll show you a few things. I don't want to show everything. I'll show you a few things. So next, you need to amend the celestial body class, right? And then to include the following double, yeah. They like to use big words. Just add. They mean add the following things. And also add the accessors and mutators. That's what they mean. So they should be of double precision, meaning the double data type. So I need to create these two variables within my class. They should be of double data type. Then I'm going to have a function that calculates a distance from parent, basically how far the body is from its parent. So I think you should take another celestial body, this function. Yeah. Then, yeah, I should take another celestial body. Then you calculate the distance. Remember distance formula, or this is the distance, or where D is the distance. Are we using the distance formula, the one that we know? I think we're using the one that we know. Yeah, the one that we know from maths. So this would be the x coordinate and what y coordinate, blah blah, of double type. So I'm gonna go here to my celestial body class, right? So this celestial body class. So I need to add two more variables, right? So I need to add. So I'm gonna make it private. So I need to add a x coordinate, right? Which is of double precision, meaning double data type. Remember, it's called, if you're using double, it's called a double precision. If you're using full float, it's called a single precision. So double precision Y coord, and then we need accessors and mutators for both these variables. So let me do that quickly. You could, remember, you could do this. You could go here on source and then generate getters and setters. That's up to you. I would just simply type them. So let me start here. So I'm gonna say public double get x. Yeah, let me say get x and get y. Keep it simple. I don't want to say get coord, all those things. It's gonna complicate my life. So x coord, the x coordinate, and then double get y, and then you have return y coordinate. These are accessors, right? Then you're gonna have your thingy. What is it? The Java doc. I'm not gonna put it. Oh, so that's how he's structuring it. So the way he's structured, it doesn't matter. It really doesn't matter in what order you do. I'm just trying to follow his order. Then double x coordinate. Then this dot x coordinate is equals to x coordinate, and then not double void. And then after get y, I create its own mutator, set y, which takes in the y coordinate. And then this dot y coordinate is equals to y coordinate. And then yeah, you're done with that. Then you'd have to create the distance function, right? Distance from parent, right? By parent, how far the body is from its parent. So each celestial body has its own parent, right? If I'm not mistaken, let's check. If you remember the celestial body, right, it has parent, right? It has the parent. So you're gonna use this parent and compare. So that function, I don't think you should take in a parameter because it's already part of the class. So you're gonna have public distance, right? So it calculate I think it's called get or distance from, but I think it should return the distance. Yeah. So distance from parent, simple. Then you use I'll just write it. You use the distance formula from maths, right? From your maths class. And there's a class that's very useful in Java when you're doing maths related things. It's called the math class, like this. Then you say dot, there's many constants, there's pi, there's tau. I don't even know what tau is. Yeah. Or the ratio of the circumference of a circle to its radius. Oh, I don't know maths like that. So there's apps for absolute, there's different arctan cores, ceiling, cell division. There's a lot. Go search the math class. So here I'll just return 0.0 like this. Yeah, just leave it like that. And then yeah, you should calculate the distance from that. And then you need to have an I updatable interface, right? With a single non-returning method called update, which takes in a double time. Non-returning, it means it doesn't give you back anything. That's what it means, non-returning English. So I'm gonna go to my models package. So I'm gonna go to my models package, then right click on it. Then I'm gonna say new, and then I'm gonna create an interface because it's supposed to create an interface, right? Then I'm gonna paste that interface name that they told me to use. Then I'm gonna click generate comments. To just generate comments, you don't necessarily need to do that. Then click finish. And then inside of my interface, I'm only gonna have one thing, right? One function, which is called update, which takes in the time. And it doesn't return anything. Just remember. So it's gonna be public. You can, because Java it does put in those things automatically. With an interface, you can just start writing it like this. Just know that it's gonna make it public. But then we don't want it to confuse it and make it a package private. So we're gonna say public void, and then we're gonna say update, which takes in the time, double time, then done. Then don't forget to put in your details here. Your details here. Don't forget to put your details there. It updates, takes time. Done. Simple, straightforward. Then I think Celestial Body is the one that's supposed to implement it. So let's go here. Um, it shouldn't come to as a surprise that celestial bodies exert a gravitational force that can cause other celestial bodies to orbit. Figure 1 shows the example of celestial bodies orbiting. To achieve this, you need to create an what you will then need to realize the interface to update the celestial body coordinates using. Oh, okay. So that's why they say create accessors and mutators, because you're going to have to use that formula to update those X and Y coordinates. So yeah, there's quite a lot in this package is really involved, but it's also easy. So you need to implement that I updatable interface. There's some functions that you need to use, right, which are very useful. So you see the whole degrees to radians things is you guys did maths 1B, you should know that you need to convert to the right degrees where t is between 0 and 2 pi, right? So that would mean wait, what is r? Where d is the distance, and then t is this. Yeah, okay. R would be okay, so this represent baba. Yeah. So there's functions that I want you to be aware of. There's this function called inside your math class, right? So there's two radians, which converts any degree in any angle in degrees to radians. Then there's 2 degree, which converts any angle in radians to degrees. So you can use those functions and play around with them. There's also, remember you guys are supposed to use cos and sine, right? So just say math.cos, and then you pass the angle. But then remember the angle is passed in radians. So that means if you receive an angle in what is this in degrees, convert it using the math to radians function so that you pass in radians. And then we also have the sine function. There's also hyperbolic sine. There's also arc sine. So yeah, there's everything is you need is in the math class. To be honest, I didn't see the reason for them to put this. You don't have to convert yourself here. Here, it's up to you. Maybe you want to calculate, you have time. You want to calculate, convert, but there's functions that do that. There's no need. And then that's pretty much all you need there. So let's talk about file handling a bit, right? Yeah, so we're doing binary file handling, right? So I think that's the main thing I should explain in today's tutorial. That's binary file handling. So I'm gonna open Notepad. Oh, let me not open Notepad. Let me open pro.io. So Chrome, and then I'm gonna open pro.io. Then I want to explain the whole concept of the stream, right? File handling. So I would have to write some notes first. So let me open Notepad. So you might ask yourself, why are there so many things that we need to know when it comes to binary file handling? Like, why so many things? Before we get to binary file handling, let's discuss text files. So text files, right? Text files. They use something that we call it's called encoding and decoding techniques, right? So encoding is simply the process of casting the string, the letters, right, or the characters, the letters to binary, right? Because remember, even if you have a text file, right, it actually stores it in binary. So when you open that text file inside an app like Notepad++, it does what we call decoding. So it translates from binary to letters, right? To basically a human readable form. That's what we call decoding. Decoding is basically the opposite of encoding. So it's like we're converting it from binary to letters. That's what we call decoding. So you need to understand those two terms. So when you write to a file, right? So when you write to a file, a text file. Let me be specific. When you write to a text file, it uses encoding, right? And how does the encoding work? So this is how the coding works. You start writing the text. So let's say you write the capital letter A. You are writing it to the file. So the capital letter A, when you write it to the file, it converts Java, right? Converts it to 65. It's integer equivalent, right? Because each can remember letters in a operating system, right? Or in your computer. Files or text is how do I put it? Letters themselves, right? The characters. Each character has its significant integer value, right? So they use that technique whereby each letter has its own integer value. We call that the ASCII. It uses the ASCII approach, right? To ASCII table, right? So what happens is that when you write a text file, it's going to look for its integer equivalent, the integer value for that character, then use that integer number. But then remember, computers, they don't use decimal system. They don't use DEC. Remember, we use DEC or decimal system. By DEC, meaning 10 digits. Those 10 digits, it's 0 through 9. Those are the numbers that we use. The computer uses binary number system. Taking you back to ComSci 1A, when you're doing number system, abo hexadecimal octal. Remember that chapter, very important here. So this you have to convert this to its binary equivalent, right? So this will be, I don't know, I'm not gonna go to Google and put in the exact number, but then it's gonna be translated to its actual binary number because at the end of the day, computers can only speak binary. So even if you write to a text file, the computer will translate it to an integer, then to a binary number. Then the computer knows, oh, you mean A. So computer, when it reads this, it reads it, oh, as the letter A. So this whole process from when translating from letters to the binary number, we call this encoding, right? You are encoding. And then the other way, in the other direction, we call it decoding, right? So from this side, which is from here to the number 65, then then it goes to the AXA table. It looks for which letter is represented by 65. Then it finds out, oh, it's A. So the decoding part, right? You see this decoding part? This is what happens when you open a file inside Notepad++. So it translates it from those zeros and ones. The thing is, everything is done so fast that you guys it abstracts there's a lot of abstraction from the end user. So certain things, certain details we miss because most of the time the programs they are fast, they do things fast. You tend not to see things how they really are. So as you can see, text files they are actually very slow, right? You can see the problem here. This is just translating one letter. What if I have a file that has 2 million lines? Imagine the time it's going to take to translate each line. That's a lot of time. So this is very limited. It has its downsides. It's cool because we can read the file. It's fine, but then it's kind of slow. So that's why we have something that we call binary file handling. So binary file handling is basically you store the file or the contents of the file. They're stored in binary. And when you read it, you read the binary itself. You don't translate or anything. You just read the binary itself. So the file is always stored in binary form. So if I try to open here, let me go to the starter file, go to data, then you see the .dat folder or bin. Sometimes they call it .bin. So there's the bin folder. You see, it's in binary. It's written in binary. You see, you can barely read. You can't even read it. So, but then there's something that's very important. Let me see if it's there. Okay, it's not there. It was supposed to be there here. I don't see it. But you see, this is binary file, very complicated, right? But it's fast in terms of reading. It's gonna be instant, just like that, compared to a text file whereby we have to translate to its ASCII value, then from ASCII value to the actual letter, then we concatenate those letters to form that word, then that word forms the sentence, then forms a paragraph. So it's a lot of time doing that. Whereas the binary file, we just store it in binary. So we store it in binary form, then read it in binary, read it in binary. We don't read it in text. No, we read it in binary. That's why we're not going to use a scanner because a scanner is mainly for text manipulation when you're doing something that is text. So for example, standard input stream, when you get input, that's text. So scanner is very useful in that sense. But remember, there's a lot of things that go into place here, right? So yeah. So remember, so there's something that we need to talk about. Remember that a file, right? A file, if you just write in Java and you say they say the file is called file.dat, Java will think this is just a string. Remember, we would have to pass it inside of a file class, right? So this has to be passed inside a file class, right? So that Java now knows, oh, I need to treat the string as the name of an actual file. So I'm actually referring to a file. So that's why we have the file class. But then the file class, just remember that the file class does not have methods for reading and writing to or from file. So just remember that the file class does not have those methods. You cannot read from the file from the file. You cannot write to the file. That's it's very limited. That's the problem with the file class. So that's why we end up using other classes to actually that give us functions to read from the file and write to the file. But then we would have to tell Java that, listen, this is a file. Once it knows that this is a file, then we can read from that file. Then we're going to have something that we call, so after after this, right, we're gonna have, we could, I'll just explaining the file part, but then you don't actually have, when it comes to binary file handling, things are done a bit different. We don't have to use file. We use what we call file input stream and file output stream, right? File output stream, right? So this is the streams, right? Remember streams, they help us to transport data. It's like tunnels, just like those pipes when you, yeah, it's a very bad example, but just like those pipes when you flash that send all that shit down the pipes. A stream is like that. And then all that water that's being transmitted, just view that as the zeros and ones. So this helps us to transmit and receive bytes of data. That's what these classes are mainly for. And then you also, the main important thing that you need to understand or look at here, we are saying it's a file, not because if you omit the file part, right, it will think, oh, you mean the standard input stream. So you see the problem with that. We need to tell it, no, it's the file, it's the input stream, right? That means I'm going to receive it via the input stream. I'm going to receive bytes of data via the input stream, but I'm receiving it from a file. So hence, one word, it's going to be file input stream. So this is to receive bytes of data from a file. Bytes of data is just zeros and ones. If you still remember that um, 8 bits is equivalent to 1 byte. So when you say bytes, we mean a lot of bits. Bits is basically binary digits. Binary digits is basically zeros and ones. So at the end of the day, it's still zeros and ones. So file input stream, that's when you use it to receive the bytes of data. And then this one is to send bytes of data to a file. That's when you send the bytes to a file. So this helps us to do that. But then they also kind of limited too because they only allow us to receive bytes. You see the problem here? We receive bytes of data. If you wanted to translate or wrap them in such a way that you can read it in the right form, you'd have to use something called a data input stream or a data output stream class. That's if you're working with what I call primitive types. So I would have to actually need a diagram to demonstrate this. So, and if you guys really read the textbook, it is there. All of this information, I'm taking it from the textbook. I simply went to the textbook and I read the textbook. So don't be like, yeah, genius, blah, blah. No, no. Just read the textbook. You realize everything you need is in the textbook. And this, I think this is the second time I'm making this example. So there's the stream, right? So I'm gonna put it in the direction. I want you to pay attention to something, right? In the direction that it's in, where the hole is, that's where it's coming in or it's entering. Then in that direction, in the other direction, that's where it's going. So I will have this here. This will represent my, remember we're talking about files, my file input stream. So that means we're gonna have some file. The input, the stream that we are referring to is no longer the, remember we in the previous practicals, where the stream that we're referring to was the standard input stream, meaning the console, right? So that's where we're getting input. Now we're dealing with file input stream. So hence that, you see that word file, it tells the computer that, oh, it's an input stream, but only for files. That means I can only receive data from a file, not from the standard input stream. So this will be file output stream. So let me put it like this. So file output, it's outputting. Okay, doesn't matter. In either way, it doesn't matter. I'll be able to demonstrate what I want to demonstrate. So imagine you have your file here, right? There's your file, right? So this is your file. Let's say, what is it called here? layout one dot dot. So layout one dot dot. Right, this is your file. Yeah, I think the main problem with students is not being able to picture the problem or the solution. That's why it's hard. It's even harder to come up with the code if you can't picture it. So that's why I like to make diagrams. So there's the file. And then when you read from the file, you send it here, right? Yeah, this needs to be vice versa. Because remember I told you where the hole is, that's where it's incoming, that's where it's entering. I'll share the diagram. I'll create an image, convert it to an image and share it in the group. So this is your data, right? It gets, remember what I talked about. We're dealing with binary files. Remember this file is zeros and ones, right? So these are the zeros and ones, right? So these are the zeros and ones. And then I need to give it some color. And then those are zeros and ones. So these zeros and ones, they enter via this tunnel or this pipe called the file input stream. So this file input stream, all its purpose is to what? To read from the file. So when you read from the file, that means I am receiving. There's something that's incoming or input. Hence, it's called file input stream. Then it travels via this tunnel and it gets passed to our program here on the side. So it's going to travel here. So I'm just going to put it here. So it's there, it's traveling. But then there's a problem here that we need to address before we continue, right? I can put it at the top here. Yeah, let me put it at the top and then put the name on the top. So I'm going to put the names on the top. Yeah, I'm just going to mix colors, whatever I feel like mixing with. So it's going to here. So it goes from the file, it enters, it passes via this pipe, the file input stream. Those are the zeros and ones. Then those zeros and ones, the file input stream and file output stream classes, they have limitations. Remember, the first limitation is that you only read bytes. Basically, you have physical zeros and ones. What am I gonna do with zeros and ones? The user can't interpret that. They don't understand that. And what also am I going to do? I can't even find whether it's a string or calculate. What if I want to calculate a sum or something? You see, it becomes very difficult. So I would have to wrap them around into, let's say we're dealing with primitive types. That means, let's say our file stores primitive types, right? We'd have to pass it via another pipe, right? Via another pipe. So this pipe, we call it, this is only when you're dealing with primitive types. Just keep that in mind. When working, basically when reading or writing um, primitive types. Primitive types is fundamental types. That's why it's very important to study. It's int, short, double, float. Basically any type written in all small letters. That's what we call a primitive type. Another word for primitive is fundamental or basic types. Then reference types, they're in their own group, right? So basically a type that's not a reference type, it's a primitive type. So to write, and when working to read that, we need to pass it via data input stream and data output stream, right? So if we want to read an int or a short or whatever, even strings, yeah, even strings, if we want to read also primitive types and strings, right? If we want to read those things from the file, we need to, after passing it into file input stream, we need to pass it into the data input stream so that it wraps or it interprets those bytes as an int or as a string. And then we have data output stream when we want to write those primitive types. So this would be file. This would be data input stream, right? Then this would be data output stream, right? Remember, this is the opposite direction because it shows where the information is coming from. Data output stream. So we're talking about, remember these zeros and ones that I wrote, let's imagine it represents the letter A. Just imagine that's what it represents. So I'm making a diagram to show you when you're reading when you're reading primitive types or you're writing primitive types to a file. So that's the example I'm making right now. And if you want to write objects, right, basically anything that's a reference type, you simply change data and replace it with object. So it'll be object input stream and then object output stream. These two classes you use it when you're working with objects, meaning reference types. This is when working with reference types. You use object input stream, object output stream. So that means it's going to take those zeros and ones and interpret them as that object. So if you have a celestial body, it's going to interpret it as a celestial body. So you don't need to understand how it does that. Just understand the flow, how it works. That's all you need to understand. So I would do this. I'll make my diagram a bit complicated, right? Just a little bit. I'm gonna put it here. And then I'll also put this here, right? And then it's gonna have an arrow from here to here. Because I also want to explain buffered. When you buffer the data, I also want to explain that. So it passes there, it goes there. Yeah, see, it's a whole flow. It's like it's a flow chart, right? No, this is wrong. It's in the wrong arrow, wrong direction. This needs to go from here to here, right? So we're still on the input stream side. Output stream works exactly the same way, but opposite direction. So I have this, and then I'm gonna, yeah, this side I'm gonna have my program. So here this will be your Java program on this side, right? Yeah, this diagram is it's gonna help a lot of students. I can feel it, man. That's what my intuition is telling me. I can feel it helping students really understand file handling. So remember, if file open stream, you can only read the physical bytes, which is the zeros and ones, as they are. There it is. That's why I'm showing that example in blue. Then, like I said, let's imagine those zeros and ones, they represent the letter A. Then what happens is that the data input stream, remember you say the data input stream, it's meant to translate it to the right primitive type. Depends on the function that you call. Then you pass this, it travels, and then it travels and then goes to this factory. Just I think another way to view it as factories that do something. This factory is called data input stream. It's meant to receive bytes, then interpret them as a char or as a right type. In this case, it's the char was the letter A. Then that letter A, it's going to get entered into our program, right? So let me put it here into our program. So basically, this is us reading from the file and into our Java program. Then we output to the console. So that's the flow, right? So that's something you need to really understand. So I'm going to put it here. Okay. Seems like it's taking. It's fine. I'm going to leave it here and put it this side. Yeah, it's fine. But then I hope you can see the flow. File input stream is meant to only read incoming bytes. So it only reads bytes as they are. But then what if we want to interpret them as a primitive type? So we pass it via data input stream. Then now, what about when you write into the file? That's data output stream. This is when the letter or this, let's say in your program you entered A, right? Okay, let me separate the A's, right? Let me divide them here. Let me change the colors. Let me use I don't know. Will brown work? Yeah, I think brown should suffice. So let's say brown, let's say in your program, the user enters A. Then we want to save A into the file, right? So I pass it via the data output stream, right? There's that A. It gets passed via the data output stream. Let me demonstrate it. It travels, it goes, there it goes, it travels, then it gets inside the data output stream, right? It's currently stored, it's traveling via this pipe, right? Or it's stored in this mesh, in this factory. Then this factory processes it, right? It does the processing, or no, it sends it, it does the pushing, it pushes and sends it to the next factory. Remember that factory file output stream, it's only meant to work with bytes. So this will translate it to its equivalent bytes, which is these zeros and ones. Then I'm gonna put it here like this. Then those zeros and ones are now like this, right? Then those zeros and ones, they get, they travel, because remember these factories are just meant to perform something and push it forward. Then it's gonna push forward these zeros and ones into the file. So that's basically the flow. So I hope it makes sense. But then there's a limitation when it comes to reading from the file and writing to the file and all those things. When working with, especially when working with, yeah, the file input stream. Yeah, okay, let's say data output stream and data input stream. When working with this, right, it reads one thing at a time. So it actually becomes very slow. The process becomes slow. So let's say you have ABC, right, inside the file. Okay, let's say this idea, this file stored ABC. It will read A, translate it, then put it in the program, then go back, translate B, put it in the program. You see, it wastes a lot of time. So now we're going to introduce something called buffer. To buffer data, right? And it's with buffered input stream. So where you wrote data here, you replace data with the buffered, right? Meaning it's buffered, meaning it's going to be stored inside a buffer, right? So buffered output stream. So what's the main purpose of a buffer? A buffer, it's a way to speed up the process of reading and writing to a file. So basically the way a buffer kind of works, right? It reads it in chunks. So like I said, remember I was making the example of reading A and B from the file. A, B, C, I mean. So let's say this would be A, and then this would be B, and then this would be C, right? But then imagine it's stored in binary form. So when you're working with the buffer, instead of reading, when you're working with the normal ones like data input stream, data output stream, it has limitations because it reads one at a time. It takes one, it translates, you see, and then once it's done, it takes the next, which is B, it translates, blah, 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 which is a long time. What a buffer does, right? It takes a whole chunk. So this whole three, it takes all three of them all at once. So you see now it speeds up the process. So I don't have to go three times, I go once. So that's the only reason for a buffer, to speed up the whole process of reading and writing to a file. So I'm gonna put the buffer here at the bottom. So here inside the buffer, okay, I'm gonna put it somewhere here at the bottom. Then I'm gonna put this over here, right? So I'm gonna put that over there, and then I'm gonna copy this green thingy. Then this will be buffered input stream. I want you to notice something. These classes are very easy to remember. The only thing that changes is the word before input. You see, data output, file output, buffered output. So it's always the word before output and the word before input that changes. That's the only, so it makes it easy to remember everything. I know some people might be confused, but don't confuse yourself, because this is meant to make things easier for you. That's if you understand what you're doing. So it goes from this file. Okay, So from here up until here, right? And then, yeah, so my diagrams are not going to be somewhat clear now. I need it to be clear. Okay, yeah. So there's the buffer. And then from the file, okay, and then this one goes to the file, right? And then this one comes from here, enters into the, gets passed to the buffer. Come on. I don't like this sometimes sometimes it works, it cooperates, sometimes it doesn't. So it gets taken from here, passes via the buffer, then gets passed via the file output stream, and then it gets passed to the file, right? So this is the full diagram. You can replace where there's data input stream and data output stream. You replace it with objects, but then just know it's no longer primitive types. It's objects that you're passing. That's the difference. So, like I said, it reads the whole chunk. So I'm gonna take these whole chunks, copy, paste them here, and then I'm gonna put it in the buffer just so that you see that it's a whole chunk, and then put it also in the buffer. So the buffer, its main purpose is to speed up the process and read things in terms of multiple things at a time instead of one thing at a time. So when you use data input stream or data output stream or object output stream, it goes to the file to fetch one thing, then comes back, translates, goes back to the file, fetch one thing again, translate. So you see, it's a long process. With the buffer, what it does, right? Takes a chunk. For example, when it goes the first time, maybe it takes 10 variables, 10 primitive variables, all at once, chunk, then it transports them, then it goes back, takes another chunk. So because reading and writing to a file, it's a costly operation, meaning it takes a lot of time, computational time to read back and forth to from the file. So in order to save that process, we store it in a buffer, then we just read from the buffer. So we just read one time from the buffer instead of going to the file and read, passing via these pipes again, going back to the file, pass via the pipes. So we reduce the amount of time or the number of times we pass via the pipes. That's the whole point of a buffer. So that's basically file handling. So in terms of coding, right, it should be fairly straightforward. Remember what we talked about. You need to create a file input stream when you're reading. Let's say I want to read to the file from the file. You say file input stream, then you pass in the name of the file. So in this case, it's layout layout one dot dot. But then this will okay. You remember you need to instantiate it new, right? To instantiate that object in a file input stream object. But then whatever is returned here, remember my diagram. After you've returned, you need to pass it where either a primitive, pass it via data input stream if you want to read from an input a primitive type, or you can actually pass it via buffer. You see a buffer, it saves that process, right? So you pass it via buffer. So that means you have to say copy this and then pass it via a buffered input stream. So like this, right? Or you can, this whole new instance, you can put it in a variable. That's fine. So for example, I'll just put it in a variable and say f in is equals to this, and then I pass f in here. So it gets passed. You read the bytes, you buffer them first, then you can store them. We're not done yet. Then you store them, you interpret them as data input stream or as primitive types or object input stream as an object. So this is like the flow. So you always go in that way. So you're gonna start from file input stream, then buffer it, basically pass it under buffer input stream, then pass it because I don't have enough space to go that side. So I'm putting it on the next line. Then put it and then interpret it the way you want to interpret it. Do you want to interpret it as a primitive type? Then via data input stream. If you want to read it as an object, it's via object input stream. So that's always the flow. So that's why I made the diagram so that you kind of get the flow. So I hope this makes sense. So yeah, let me save this as a PNG. Then I'll say binary file handling. And then I'll share the image in the group. So yeah, this should be it for today's class. Good luck with the practical because the only thing that's left here is reading from the file. This part, right? This part you guys can figure it out. Like I said, I showed you there's functions in the math class. Just use the math class, you should be fine. There's also pi in the math class if you didn't know. But like I said, just if you want to see what's available, you just type math, right? Then on your keyboard, you're gonna press Control followed by the backspace. Don't not the backspace. Let me show you. Hey, some people are not well versed in keyboards. When you tell them press backspace, they press the wrong thing. I don't mean you see on your keyboard somewhere here on this side there should be text written backspace. I don't mean that. I mean this. This is a backspace here. This. So you press Control followed by backspace. So Control backspace. But then you need to make sure when you press Control, don't let go of Control. Then click backspace. Then it's gonna autocomplete. It's gonna show you available methods, right? Or you can just press dot and then it shows you. That's up to you. So dot, you see there's pi. So you see the double value pi, right? So you can just say dot pi. Then there's your pi. Then you can say pi times radius squared, which is radius times radius. Yeah, so this will be your formula. So just go to the math class and you find everything you need in there. So I hope file handling is a bit clear now. Remember, we're just avoiding this whole point of encoding and decoding because it wastes time. So it's better to save the file in binary form and read it in binary form. Write it in binary form and read it in binary form. So yeah, this will be it for today's class. See you in the next session. Good luck with the practical. If you have any questions, just post them in the group. Did you understand?